Hi and welcome. In our last demo we talked about NSArray, and in this demo we're going to talk about Nsmutable Array. Now the difference is that NSArray is what we call an immutable type. It doesn't mean it can't be changed, it's just that its pieces, its parts, its indexed elements can't be altered within the context of the same array. Now an NSArray, if we change the parts, what we're really doing here is just assigning a whole new array to the same pointer, to the same object name. With a mutable array, on the other hand, we can go in and change elements. We can add elements, we can delete elements, and it doesn't change the actual pointer that the object name is pointing to. So again, these immutable types are used most often, and we only use the mutable types when the function of the application, or the function of this part of the application that contains the mutable type, depends on its mutability. So I have an example of that here with this Nsmutable Array demo application. Now this control up here is a UI text view object, and if I look at its properties, I have unchecked the editable checkbox. A text view is a multi-line way to enter text usually, but we can also display text in it, and that's what we're going to do here. I also have two buttons, add new entry and delete last entry. And if I look at my view controller, I will see an outlet for the text view only, UI text view, entry view, and it's to the text view. And then I also have the make entry and remove entry handlers, which are IB action methods, which are those two buttons. The add new entry for make entry and delete last entry for remove entry. I've also got a couple of other properties here. I've got an Nsmutable array called entries, and this is going to be an array of entries that I'll be changing throughout the course of the run. And then I've also got an integer called entry count, and this is going to, at all times, really kind of point to the last element in this mutable array. So what we're really doing is implementing a very simple stack where the add entry button pushes an item onto the stack and the delete entry button pops an item off of the stack. We're just not going to do anything with that data. Now in the view controller, in init with nibname bundle, I'm just going to go ahead and initialize this entry count integer to 0. And then I've also got a lazy instantiation here, and of course I've synthesized all three of these entries, entry view and entry count. I've got a lazy instantiation here of entries. I've overridden its getter. We did this last time. And I've just said if it doesn't exist, if entries equals null, if not entries, then entries is equal to allocate a mutable array and then initialize it with a capacity. Typically, when we don't want anything in the array to start with, we initialize it with a starting capacity. Now, this is just a hint to the compiler of roughly how big this array is going to get. It's not a limitation. This doesn't say make an array that only has 5 elements. This says start with a capacity of 5. If it gets bigger, make it bigger. It doesn't matter. So this is a hint to the compiler. If you think your array might get up to 20 or 30 elements, you might want to initialize it with that kind of starting capacity. It's up to you. And then, of course, we return entries, and this will instantiate self.entries if it doesn't already exist. So now here's our make entry button handler, and of course we get the sender. We're not going to do anything with that, but we get the sender always. We're setting up a new NS string here as a string with a format, an entry and an integer, and where we're getting that is from this entry count variable. So the first time we click this button, it will say entry 0, but then it will increment it after it uses its value. And then we're adding that object to the entries mutable array. So we can do this with mutable arrays. NSArray does not have a method add object, but Nsmutable Array does. So we're adding that string to our array of entries. Then we've got another NS string here that we're allocating, and it's just an empty string. We called it viewText. And then I'm using something called fast enumeration. This is what we call a for-in loop. So what this will do is I have two parts. I have a type and a name, NS string entry, and then I have the keyword in, and then I've got my mutable array, self.entries. And what this will do is it will iterate through every object in the array. Now those objects have to be typed correctly, so they are NS strings. So what it's saying is, get the first entry, call it entry, and then do whatever's in the for loop, get the next entry, call it entry, and then do whatever's in the for loop, and so on and so forth. So then the viewText, this new string, I'm setting equal to whatever's in there now, which is initially this empty string, and then append that entry. And then after I do this for loop, I have self.entryView.text, which is our text views text being set to viewText. Remove entry works in exactly the opposite way. First, though, we check to make sure that we don't get an out of bounds condition. We check to make sure that the entry count is greater than 0. And then we remove the object at a particular index in this mutable array, which is entry count, but it's pre-decremented, which means that if entry count is now 1, we remove the object at index 0. And then again, I do exactly this same thing. Now, I'm going to want to factor this code out, and we'll do that before we end. But this is exactly the same code. In other words, I get a new string called viewText, and I go through the entries mutable array, and I get each one and build that viewText string, and then I set my views text to that viewText. So factoring that out is going to be important because it's identical code. So when we run, we'll see what happens. We add new entry. You see that the counter is working. We delete the last entry. Counter goes back. But in every case, all the time, this text view is reflecting everything that is in that mutable array. And if we try to delete when there's nothing in the array, then we won't get the error. Okay, so let's just factor this out. Let's make a new method, and it'll be void. And let's just call it make text. Wait a minute. Oh, sorry about that. Oh, it gave me a helpful, unhelpful tooltip. Okay, there we go. And then I'm just going to grab this and copy it and paste it. And then I can just take this code and delete it, and take this code and delete it. Now, the reason I went through this part of the exercise is that we can't just do this. We can't just say make text. That's not going to work because it doesn't know what to call make text on. Unlike Java, it doesn't assume this. In Java, a new method name would assume that, unless proven otherwise, that this were the receiver. Self is not assumed to be the receiver. We have to tell it that self is the receiver. We're sending a message to self here, so we need to say self make text. And when we do that, we're all set. And then likewise, in the next piece of this, we'll do the same thing, and we'll save that, And we'll run it again. We've factored out that make text, and of course it still works. But the reason I did that is I wanted to show you that in order to call a method that is defined only in the implementation, we have to use self make text. We can define methods only in the implementation. Notice that we didn't define it here. It's not a public method. This method is private to the class. And we're going to talk about that in some more detail a little bit later when we talk about class extensions. Thank you very much.